Hello everyone, welcome back to Thinkable Physics. My name is Masood and we are going to continue our explanation about the capacitors. Last lesson we talked about the capacitors and we classified the capacitors and we said that there's no certain classification. You cannot say there are three types of capacitor or four types or so or etc. So based on the shape of the capacitor, we can classify the capacitor into several categories. But as I told you last lecture, our concentration is on parallel plate capacitor. Parallel plate capacitor is a capacitor consists of two parallel metal plates. Sometimes an insulator is sandwiched between two parallel plates. This is called dielectric capacitor. Sometimes within the or between the, let's say, parallel plates, there is no substance. This type of capacitor is called vacuum capacitor. Right? So in this lesson, we are going to charge capacitor. How do you charge the capacitor? Let's get started. I separated the process into four stages actually. The first step is capacitor is energized. Energized means charged actually. Capacitor is charged by connecting its place into two terminals of a battery. So plug it into the battery. The first step. The second step. When connection is made, charges transfer from one plate to the other. So this is the first one. Before charging, the circuit is open. So keep in mind that open circuit does not conduct electricity, right? Open circuit doesn't actually conduct electricity. What's open? How do you know open? How do you recognize open from the actually closed circuit? How do you know which is which? Actually, if you see this form, actually this is open circuit. So you have an open circuit, means there's an interruption in the circuit. That's why current or charges don't transfer. So right now, before charging, charging means transferring electron. Simply, charging means transferring charges or transferring electrons from one plate to the other. Right. This is open circuit. In open circuit, actually, there is no transfer of charges. What do you say about this one? Whenever you close the circuit, whenever you close it, actually, what's the actual shape of closed circuit? This is closed circuit. Close, right? Closed circuit. In closed circuit, electrons, actually, the circuit is connected, and electrons start transferring from one plate to another. For example, if you take a look at the first figure, so the capacitor is neutral. How do you know it's neutral? I want you to count the number of electrons and protons on either plate. Concentrate on one plate, for example. 1, 2, 3 electron versus 1, 2, 3 positive charges. So they counteract each other. On the right side, what do you say about the left plate? 1, 2, 3 proton, 1, 2, 3 positive charge, 1, 2, 3 electron. So they are neutral. So either plate is neutral. That's why actually there's no net charge on either plate. There's no net charge. Actually, no charge is carried by either plate. So either plate is neutral. What do you say about this one? On the right side, how many positive charges are there? Count them from 1, 2, 3. How many electrons are there? Just one. So here, the process of charging is started. And I told you charging means transferring electron from one plate to the other. And it's not just for capacitor, actually. We can generalize actually this process for batteries as well, right? So here, so is there a net charge on the right plate or not? On the right plate on the right side? Yes. So which charge is carried by the plate? Before I reveal it, I want you to guess the answer. Which actually which charge is carried by the plate? So the plate is charged by positive charge. It carries positive charge because we have three positive charge. The majority is positive. Go to the left, actually left side. The left plate, does the left plate carry any net charge or not? Let's actually examine it. I want you to count the number of actually either charge. Firstly, positive charge. 1, 2, 3 positive charge. What do you say about the negative charge? 1, 2, 3, 4 negative charge. That's why the right plate carries positive charge. The left one carries negative. How do you know? How do you recognize the charge carried by each plate? Just by counting the number of charges. Majority talks. Here, majority of the right plate is positive. That's why the positive plate, the right plate carries positive charge. On the left plate, majority are electrons. Electrons are majority. That's why. So we have negative charge on the left side. So right now, the capacitor is charged. We have positive and negative, and this is our objective actually. Our objective for charging is to separating the charges actually into positive and negative. We don't need them actually mixture, right? We want to separate them. But as your book mentions, it says a small net charge on each plate. So it's not fully charged. The charge is not completed. So electrons are still removing. Electrons are still transferring from one plate to the other, from right plate to the left plate. What do you say about this one? Here I can say the charge is full, the process is completed. Why do you say this? Because on the right part, on the right plate, there are only positive charges. There is not even one electron. It's wrong if I say there is not even one electron, but actually protons are predominant, right? Outstanding charge on the right side, right plate is actually positive charge. What do you say about the left part? The left part, actually, how many electrons are there? For 2, 4, 6 electrons versus three positive charges. So 3 positive charges cancel 3 proton. Here we have 3, actually the 3 positive charge versus 3 negative charge. And this is this is called charging. So simply we can say charging is a transferring electron from one plate to the other after connecting the capacitor to the battery. After the capacitor is plugged into the battery. Whenever you supply the capacitor with the source of electric current, actually the process of charging is started. And in this situation, when the capacitor is fully charged, there's actually the transfer of charges stopping, and electrons no longer transfer from the right plate to the left plate. Right. So I explained it in advance. Let me read the other steps. I think I read the second step. No problem. Let me read it again. When connection is made, charges transfer from one plate to the other. The third step, eventually an equal and opposite amount of charge accumulates on either plate. Equal and opposite charge accumulate on either plate. 3 positive charge on the right side, 3 negative charge on the left plate. The last step, charge transfer between the plates, stops when the potential difference between the plates is equal to the potential difference between the terminals of the battery. Let me write it symbolically for you. Mathematically, I can say when the charging is completed, delta V of the capacitor, delta V between the plates of the capacitor, like this. I say capacitor, delta V of the capacitor is equal to the what? Is equal to the delta V of the battery. Delta V of the battery. When this condition is provided, when this condition is satisfied, so I could say capacitor is charged completely. Right. Let's move on to another subject. Capacitance is the ratio of charge to what? Is the ratio of charge to potential difference. This is the title, the ratio of charge to potential. And I can say it's another definition of capacitance. Mathematically, I can define it like this. Right. So capacitance is measured by, C is measured by Q over delta V. So this is the first rule for capacitor. C is equal to Q over delta V. The SI unit of capacitance, farad. Farad actually is named after Michael Faraday. Michael Faraday is a very famous scientist in physics. So the unit of the capacitance is farad. And farad comes from what? What's the origin of farad? Farad is equivalent to coulomb over volt. Coulomb over volt is the actually value of farad. Right. Another definition of capacitance. Let me jog your memory about the first definition of capacitance in the previous lesson. In previous lesson, we said that capacitance is the ability of conductor to store energy in the form of charge, right? Ability of conductor to store charge. But right now, mathematically, we take the definition of capacitance from the equation. I can say capacitance is the ratio. You see, ratio of what? Ratio of charge to the what? The potential difference. So based on the equation I've mentioned it. See, based on this equation, capacitance is the ratio of charge to potential difference. Right. I'm not gonna answer these questions. I want you to think about these questions and circle the correct answer to make sure you understand the subject or not. Right? So we have 3 questions. I'm gonna leave it for you. Let me read the first question. I just read it. I don't explain it. I don't circle. Number 1, keyboard button of a computer is an example of, we have 2 options, either parallel plate or spherical capacitors. Just circle one type. Number 2, choose the parallel plate capacitor from the following. Which one is parallel plate? Flash attachment in camera, flash of camera is the parallel plate. Number 2, buttons in a computer keyboard, button in the computer. C, A plus B. A plus B means both options. It means flash of camera and computer keyboard buttons are capacitors or not, are parallel plate, and the earth. Right. Number 3, choose the electrolytic capacitor from the following. Electrolytic, flash of camera, we have the same options. Flash of camera, buttons in computer keyboard, both options, A and B, or earth lonely. Right. Let's move on to another actually title. The title is the terminals between the capacitor plates can change its capacitance. Uh, the material, excuse me, the material between a capacitance plates can change its capacitance. Guys, I'm gonna leave this subject for the next lesson. I appreciate you for being with me, and bye for now.